All right, here are perfect problem 6 solutions. Um, we're asked to make a bunch of confidence intervals. So maybe I'll do number 1 over here. We have a random sample of 60 sports fans. So n is equal to 60. The average number of times per day they thought about football. Okay. X bar, maybe I'll keep this in the line. X bar is 80. And a standard deviation is 20. What's important is that that is S, not sigma here, because this standard deviation is just from my sample. It's not from the population. So I want to create a 99% confidence interval for the mean number of times per day that all sports fans think about football. So I got to do shape, center, and spread. The shape, well, it's approximately normal because it always is, and also, more importantly, because n is greater than or equal to 30. And maybe I'll write parenthetically, it's a t distribution because sigma is not known. The center, we don't know mu. We're trying to make a confidence interval for mu. My best guess, my point estimate, maybe I'll even write that. My point estimate is 80. And the spread, well, since we're talking about a sampling distribution here, what we have to do is it's going to be S divided by the square root of n. And in this case, S is 20 and n is 60. So we get 20 over the square root of 60. I guess I should figure out what that's equal to. If you calculate this, you get your spread is 2.58. So what we want to do is create a confidence interval. Let's try that again. We want 99% of the data in the middle. So we want this to be 99%, which means we want this to be 1%. No, that's not true. We want both of the tails combined to be 1%. So we want that to be half of 1%. In other words, 0.005. And the value here corresponding is a t-value. It's a t-value with, maybe I should write over here, 19 degrees of freedom. And so if you figure out, I guess really this is negative t, and this over here would actually be what t is. And if you go to your t distribution and you go to the 19 row for degrees of freedom, and you look for the area in the right tail is 0.005, what you get is 2.861. So from that we can calculate our confidence interval. Our confidence interval is going to be our point estimate 80 plus or minus 2.861 of these standard deviations, which is 2.58. And if we do 2.58 times 2.861, what you get is approximately 7.39, maybe we'll call it. So what that gets you is 87.39 is the top end of the interval, whereas the bottom end of the interval is 72.61. So there's our confidence interval. Yeah, I guess that's good enough. For this picture, you kind of have some options. I mean, the way it's drawn here, I have 0, I have a middle at 0 because these are the t values. Do I want to leave it like that? Yeah, I guess that's fine. Whatever. Okay, so number 2 is very similar. The only thing that's different is that the standard deviation of 20 comes from all fans, not just the 60 in our sample. So the only thing that changes is that instead of S equals 20, we've got sigma equals 20. So n is still 60, x bar is still 80, And now we have sigma equals 20. And so our shape is still approximately normal. And it's still because n is greater than or equal to 30. However, now it's a z distribution because sigma is known. My center, still the same. Still my point estimate, x bar, which is 80. And my spread, also still the same. It's now sigma divided by the square root of n, which is still 20 over the square root of 60, which is still about 2.58. So what's going to change is our picture will be a little bit different. We'll still make this approximately normal picture. We still want a 99% confidence interval, so we still want 99% of the data in the middle, which still leaves us with 0.005 here and 0.005 here. But now we have z values out here. The z value, maybe z sub 0.005, whereas this is t sub 0.005 is equal to that thing. So this is saying how many standard deviations do you have to go over with the z distribution if you want to get 99% of the data in the middle, and the answer to that is 2.576. So what we get is that our confidence interval is 80 plus or minus, instead of 2.861 standard deviations, 2.576 standard deviations. And that's 80 plus or minus, but I need to know what 2.576, pull out my calculator real quick, 2.576 times 2.58. Just coincidence that those are really close. And what you get is 6.65-ish. So what that gives you is a confidence interval from 81.35 all the way up to 94.65. Write it like this so it looks like an interval. And that's the answer to number 2. And we do it one more time. It's kind of a long problem. Ooh, a little bit low on room. Part 3 here. In part 3, it says that we have 250 sports fans. And what we need to know is what is p hat. Well, 180 of them list football as their favorite sport. So p hat is 180 divided by 250, which is 0.72. Okay, so this is all the information. Well, yeah, that's fine. That's all the information I need. So shape, it's going to be approximately normal. Big surprise. The reason why is because p hat times n times p hat times 1 minus p hat is greater than or equal to 10. N is 250, so that makes this plenty big. My center is just p hat. My point estimate here, which is 0.72. And my spread, what I need is sigma sub p hat, which is the square root of p hat, 0.72, times 1 minus p hat, which is 0.28, divided by 250. And so my spread is 0.028 if you plug all this into a calculator. And so what I get for my picture, I'm going to have to make it a small picture, is I want a, what do I want? A 90% confidence interval. So If you want 90% in the middle, that means this is 5% out here, and z sub 0.05, z, because it's a proportion, those will always be z's, is equal to 1.645. So my confidence interval goes from my point estimate of 0.72, and I got to go up or down by 1.645 of these standard deviations. Each standard deviation is about 0.028. So what you get, if you multiply 0.028 times 1.645, is about 0.047. So what I get from my confidence interval is if I do 72% minus 4.7%, I get 67.3%. And if I do 72% plus 4.7%, I get 76.7%. And fortunately, that's the end of the perfect problem because I am out of room.